series.
Uh,
So next is sum to infinity. It's going to be much easier than the stuff we were doing before, I think.
yeah.
Um, and so the formula for it is a over 1 minus r. The difference is, so if you have a normal sum, the numbers are just going to keep getting bigger and bigger. It's like 2 plus 4 plus 8 plus 60. And if that goes forever, it's just going to be infinity. For it to not go forever, the common ratio has to be in between 1 and minus 1. So it has to be a fraction. And so the numbers eventually become 0. So that it actually has it's called convergent. It has an end point. Okay, let's try this.
If the fourth term is 1.08, would I need to put like two gaps next to it and then put the 0.23328 there as well?
Yeah, you could do that. Sorry, my pen's a bit weird. There we go. So 1.08. That's the fourth, fifth, sixth, and then seventh. Okay.
And then could I then find the difference between those two sums and then divide it by 2?
This is geometric. So it's times something each time.
That's why I find out the common ratio.
Yeah.
So is that like 1.08 times something divided by 2 is equals to 0.23328?
Not quite. So this would be 1.08 times r.
Yeah.
What would be the next one?
1.08 r squared.
Yeah. And so what's next?
Would it be like 1.08 times r equals to 1.08 r?
What I would do is, what would be the third one?
Would it be like 1.08 r squared times r equals to 1.23328
Yeah. What is r squared times r?
r cubed?
Yeah. So 1.08 r cubed is equal to 0.23328.
I can just put that into my calculator.
Yep.
.6.
Okay. Show that question.
What does convergent mean again?
It has an end point. So eventually you'll just be adding 0 each time. I think so you would need the definition for it, and so for that you would just say r is between 1 and minus 1. Like the magnitude of r is less than 1, therefore convergent. So just put at the end, like basically r is between 1 and minus 1, therefore it's convergent.
Yeah.
It's basically the magnitude of r is less than 1. If it was like, if r was 3, the numbers would just keep getting bigger and bigger and bigger. But here, the numbers will get smaller because you keep multiplying them by a fraction. And how about b?
This is where I do like a over r minus 1,
1 minus r.
1 minus r, sorry.
Mm-hmm.
And so would I need to first of all find out what the first term is?
Mm-hmm.
Would that be 1.08 divided by r cubed, or
0.8 over
0.6 cubed?
yep.
I've got 5.
That's great.
And so my answer to the sum to infinity is 12.5.
Equals 12.5. That's it. And well, I'll just take a look. So 12.5, correct, is 5. The series is convergent as the magnitude of r is 0.6, which is less than 1. Show that question. Let's just make a little sense out of this. Table. What are we doing here? We are doing 0. Sorry, first term was 5. 5. Is this how it will work? 5. Oh, I'm just trying to make the equation of it. Yeah, 5 times 1.0. No, sorry, 0.6. 0.6 to the power of x. I'm going to start x from 0, go to 10. And so fourth term was 1.08. Yeah. And so this is what you get each time. So first term is 5. Times it by 0.6, you get 3. Times that by 0.6, you get 1.8. And so it's just times, times, times. So it's all these numbers added together. So I'd make a sequence like 5 plus 3 plus 1.8 plus 1.08. But you can see the further down you go, because you keep multiplying by 0.6, the numbers keep getting smaller. And you can see there it's using standard form because they're getting tiny. And if you do that for long enough, so my calculator stops there. If you do that for long enough, you can see how the numbers are getting very close to 0 and eventually it's just 0.
Yeah.
And that's why it's what's called convergent. Basically, it stops at 12.5. Another sequence would be divergent. Numbers just keep getting bigger, and so it's just infinity. Any questions about that?
No.
Okay, so that's just kind of what it looks like. Okay, let's try this.
So should I first try and oh no. So sum to infinity is a over 1 minus r. So is it like a over 1 minus r equals to 16?
Mm-hmm.
And then should I try and find this solve no find that make r the subject to
Let's do that in a minute.
um I'm not really sure where to go with this.
Sum to 4 terms. Do you know sum to n terms?
No.
That is the other one. So sum to infinity is a over 1 minus r. Sum to n is what was it? I think it was a r to the n minus 1 over r minus 1.
Yeah.
I think that was it. So just create an equation. Sorry, something like that. Right, I'll be in 6 minutes if you need me, Chief, okay? Can we take a break for that? Sorry about that. Yeah, what did you get there?
Um, so I'm not really sure because I know how to get A, and I'm not sure how to get A here.
Um, so the way you created an equation for the first one, like that one is equal to 16.
Yeah,
What is this one equal to?
16.
This is sum to 4 terms.
So equals to 15.
Yep. And you do know one of those things in there. Do you know what it is?
No.
N. N is 4. And so that's it. Minus 1. And you have to find A and R. How do you do that?
So for A, would I have to divide 15 by the fractional?
Let's see. So it's like what you were saying earlier about making R the subject. I'm not sure which way is easier. Let's make A the subject in this one up here. What would it be?
Sorry, did you say make A the subject?
Yeah.
Okay. So A equals to 16 minus 16R.
Minus 16 R. And so, how can you use that?
Sub in 16 minus 16R into the equation.
Yeah. So, 16 minus 16 R. R to 4 minus 1 over R minus 1 equals 15.
Yep. And can I put that into my calculator?
Yep. And it helps to do like press fraction button first when you're in the bracket.
I've got a half.
A half. So R equals a half. It's saying possible values of R, I notice.
That's because it's got R to the power of 4. So
Yeah.
should I do the thing where you make x equals to minus 999 or something?
We can try it.
I've got minus a half.
Great. B.
So how do we know there's only 2 values?
Right. That's a good point. Because it's a quartic, there could be 4.
Okay.
Yeah, that's a good point. So the only way to do it could be quintic, because 16R and R to the 4, that'd be R to the 5. We could expand this whole bracket and do it that way.
Okay. So
Any idea how to do that?
is that 16? Is that 16 r to the power of 4 minus 16 minus 16 r to the power of 4 plus 16? Is that like 16 over r minus 1 or something?
I think so. To make it easier, I would bring the denominator to the other side first.
Yeah.
So we expand these brackets. 16r to the 4 minus 16 minus 16r to the 5 plus 16r. Okay, what is next?
Makes the entire thing equals to 0.
Yeah.
And so, yeah, minus 16r to the power of 5 plus 16r to the 4 plus r minus 31 or something like that, I think.
I think it will be, yeah, minus 16 plus 15.
Oh, right, yeah, sorry. Minus 1.
Yep. Does our calculator even do that?
The graphical one does, I think.
Oh. Go on, use the graphical one. My simple one doesn't. R to the 5, guys. Okay, equation, polynomial. Yeah, you're right. To the 5. Did you get an answer?
Not yet.
You can try. Do you know where to find it?
I only got one answer, but I'm not even sure if it's right. You got right.
There was an additional answer, and that was 1. The other 2 are imaginary answers. Okay, that's weird. Why? What did you put in?
I'm getting a bit confused with the A0, A1, A2, A3 or something.
Yeah, that is weird. It's literally just the first one is the number in front of x to the 5. Second one is the number in front of x to the 4.
Okay.
Yeah, so like minus 16 plus
Yep.
16. And then the trick is like 0, 0 because there's no cubed, there's no squared. So those 2 are 0. Then 1 and minus 1. An additional answer was r equals 1. There you go. Okay. How about the B? Oh, hang on. No. R is not equal to 1. Why is that?
Is it because that's the fraction?
Yeah, it's not. Yeah, the magnitude of it has to be less than 1. Otherwise, it would just be the same number over and over again, times by 1, times by 1. So we were correct.
Yep.
Using that quick and easy method. Okay, how about B?
So what I need to do, 15 divided by a half cubed.
Yep. Why not minus a half?
Because we reject negative numbers.
Yeah, it says they're all positive.
I got 120.
Yep, that's it. Great. So let's see how Bookie did this one. And they did the 1 minus r, yeah, which is usually used for this type. Um, 16 1 minus r 16 1 minus That's cheeky. So, what might make these easier is this bit here
Yeah.
is the same as this bit here. And so you can make one like 1 minus r the subject and then just sub it in there. It might be easier, but I think our initial easy way was easiest. Any questions about that?
No.
Okay. Let's try this. Yep. Okay. What is this?
So does that mean that A is full?
Yep.
Um, you know that. So would it be like 4/1 minus I equals to 12?
Mm-hmm.
And then I can put that as my calculator.
Yep. A third.
I've got. Oh, sorry.
Go on.
R is 2/3.
Yeah, I thought it'd be 2/3. Great. Let's see. What is A?
I'm gonna guess it'll be something like. Would it be like the series is positive?
No. It would be the magnitude of R is less than 1.
Yeah.
R is fractional. B. Otherwise, the numbers keep getting bigger.
Um. So I need to find. So A is 3/8,
Mm-hmm.
and R will be 3/8 times something equals to 3/16.
Yep.
And so R will be a half.
Okay.
So do I just do 3/8 over 1 minus a half?
Yep. And then you just get the answer. Thank you, be grand for that. And it's 3/4. That's great. Okay. This is good. How about this one?
So I need to do like 1 minus 2x r equals to 4x squared minus 8x cubed.
Doesn't work that way. I imagine these were pluses in between them. This isn't one term. This isn't a second term. It goes first, second, third, fourth. They're just swapping signs each time.
Right. So would I do something like 1r equals to minus 2x? Or
Yep.
even r is equals to minus 2x?
Yep.
And so I then need to do like minus 2x times r no times minus 2x times minus 2x equals to 4x squared.
I believe you're just going to.
Oh, so I just do 4x squared times minus 2x equals to minus 8x cubed, and then put it into an equals to 0, or
I mean, that's just an identity. You'll just literally get you'll get zero. You'll get like that's literally true. Minus 2 times 4 is minus 8.
Yeah.
X times x squared is x cubed. Um, any idea what this is about? Range of possible values.
Um, no.
That means it's an inequality.
Right.
Where have you seen an inequality with these infinite geometric series?
Um, is it when? Not sure.
Magnitude of r is less than 1.
Oh,
And so we want range of possible values of x.
so is it hmm,
What is r?
minus 2x?
And so the magnitude of minus 2x is less than 1. They want an inequality with just x. So another way of writing this is that is between 1 and minus 1. What is x? Range of possible values for x.
X would be a half and minus a half.
Yep, that's it. Basically, the magnitude of x is less than a half. That's the range of possible values for x, between minus a half and a half. Yeah, the magnitude of, so it's convergent. So the magnitude of r has to be less than 1. R is minus 2x, and so magnitude of minus 2x is less than 1. And then you just say magnitude of x is less than a half. B.
So so a or even would it be 1 over 1 minus um minus 2x?
Yep. And it's kind of my own fault for deleting the thing, as I imagine it's a 1 mark question. There we go. And they minus minus just turned into plus. And then, yeah, x is between a half and minus a half using that. Any questions there?
No.
Okay, let's see this one. Convergent. For given that's. All right. How about this one?
So um so a is equals to 4,
Mm-hmm.
and so 4 over 1 minus r
Mm-hmm.
is equals to 20 times 4r cubed.
This is not the fourth term. This is the sum to four terms.
Um,
Do you remember sum to n terms?
that was like R to the N and stuff like that.
Yeah. I'll flip them around. R is now less than 1, and so it kind of makes sense to do it that way, but it gives the same thing.
And we know what, so I need to just put that formula into that.
Yeah. So what are we doing? 20 times.
For 1 minus R and 1 minus 4 minus R.
Yeah. Problem is we've got two unknowns there. We have R and N.
Would N be 4?
N is 4.
And can I then put that into my calculator? Or
Yep.
I got like a really bad number.
It says 4 significant figures.
So then it would be minus 0.9873.
Okay. Shift solve. Okay. Let's take a look. They're saying plus 0.9873. Oh, First term is 4. Let's see. Bad question. They should have either said values or they should have said something like that all the terms are positive because there are multiple answers, just like with the, because it's r to the 4, just like the previous one. Any questions about that?
No.
Okay. Not a great question. Bad bookie. This looks very similar in a convergent geometric series. Okay, very similar. How would you do the first one, Partey?
So that would be 2 over a, oh no, sorry, 1 minus R
Mm-hmm.
equals 16 times 3, and then
How'd you get 3?
uh,
N is 3. Do you remember formula sum to n terms?
like A, and then R, right, and then 1 minus R to the N
Mm-hmm.
over 1 minus R.
Yeah.
So it would be 16 times 2.
Yeah.
1 minus R to the 3 over 1 minus R.
That's it. And then you just put it in your calculator.
Yeah. I don't know if I played it wrong. I said cannot solve.
We might need to simplify it a bit. I realized, what would you get if you multiplied both sides by 1 minus r?
You'd get 2r over 1 over.
And what would be on the left side?
Would you just get 2r over 1 minus r?
You would just get 2 because you're multiplying by the denominator.
Oh, 1 minus r. All right, yeah, sorry. So, yeah.
And how about on the right side?
You'd get 1 minus r. Would you just get 1 minus r cubed? 2 times 1 minus r cubed.
Yeah, and don't forget your 16.
Yeah.
Yeah. And that's probably solvable now. If you like, we can see it through to the end, or whatever way you like.
Yeah, so now you could just do like 2 over 32 equals to 1 minus r cubed.
Yep.
And then you can just do 0 equals to minus r cubed. And then whatever 1 minus 2 over 32 is.
2 over 32. So 30 over 32.
Yeah.
Okay. Plus 30 over 32. And then calculator for that, is it?
Yeah. Um, 0.9787.
That's it. 4 sig fig. So that one we couldn't solve it, and so we just had to go through to the end. But and this method would work actually with the previous one. Yeah, they're both over 1 minus r, so you can times them both by 1 minus r, and that'll make things easier. 0.9787. Any questions there?
No.
Okay. Let's see this. Sum to infinity is that. Hang on. Sum. That's easy. It's easy. Just go through it. Okay. Sum to 4 terms. The only one worth doing is question D. The sum. Let's do just question D.
So is this where I'd have to use the formula like a times, or even, sorry, 30
Mm-hmm.
times 1 minus 7 over 8 n over 1 minus 7 over 8.
Yeah. What is 1 minus 7 over 8?
1 over 8.
Yeah. Sorry, I shouldn't have interrupted. Sorry, go on.
And so does it say what that's equals to here?
Kind of.
So it is equals to. Is it just an inequality equals to greater than 180?
Yeah, greater than 180.
And then can I put that into my calculator?
Yeah, it'll probably work.
I got 0. I got like a bad number as well. I got
Uh,
0. Sorry.
yeah, go on.
0.1383.
Oops. And so, what do we do with that?
Do we just say that 0.1383 is greater than 180? Oh no, it's smaller than 180.
Smallest possible value of n. I was not expecting an answer like that. If I was to do this manually, I would do 180 divide by 30 times by an eighth, which is 0.125. That's 3/4. So 1/8 to the power of something gives you 3/4. 1/8 to the power of something gives you 6/8. Six-eighths. Okay. I think. Hang on a second. What are we missing here? The sum of the first n terms of the series is greater than 180. Calculate the smallest possible value of n is greater than 180. Oh, no. My mistake. Sorry. I'm an idiot. Bidmus is the problem. See this one on the top, 1 minus 7 over 8 to the power of n?
Yep.
We can simplify that down to 1 over 8. So the denominator can be simplified down to 1 over 8, but the top can't.
Okay.
So just put in the top as 1 minus 7 over 8 to the power of n, or x. Say, why do I ever not use the calculator? And 7 over 8 is a bit weird. But you could just do 7 over 8 and see what it is as a decimal.
I'm a bit confused as to what's going on.
Oh, sorry. So just put it into your calculator again,
Yeah.
except just leave it as 1 minus 7 over 8.
Okay.
Yeah, my mistake, sorry. Bid miss. Can't simplify it. I'll just check. Shift solve. Okay, we get this number. So this is more like what I thought we'd get. And so what do we do with that?
Um, we should we just get it to like three sig fig?
Smallest possible value of n.
So would we do like 10.38 is equals to n or something? Or
So the term is like the 10 and a half term.
yeah.
No such thing.
Oh, 10. Oh, n smallest, is it that the smallest value of n is 10?
Too small. It wouldn't be greater than, it'd be slightly less than 180 at that point.
11?
Yep. For these, you always have to round up. N is 11. That's it. Yeah, sorry, I just messed up that bit there. You were right first time. Just leave it as 1 minus, just put the whole thing in the calculator. And then it's just the next term. Let's see. That was okay. That was okay. N is 11. There we go. Any questions about that?
No.
Okay, let's see. The second term is this. The sum to infinity is 10. Okay, let's do part A.
Okay. So AR is equals to 12 over 5.
Yep.
And so uh, 12 over 5. And so R is equals to 12 over 5 over A.
Yeah. And that's the same as 12 over 5a.
Yeah. And so would I do something like so the sum of infinity is 10, so would it be like 10 is equals to um oh should I do it the other way around and do
Yeah, I think it'd be easier the other way around.
so 12 over 5R
Yeah.
is equals to oh no over sorry divided by 1 minus 12. Is it not the A over 1 minus R here?
Oh, yeah, sorry. It's a over 1 minus r 12 over 5. And maybe I'll regret this, but hang on. 12 over 5 is 2.4. I'm using 2.4. 2.4 over 1 minus.
Is it 2.4R?
Ah, yeah, sorry. What am I doing? I will regret it. Why do I do it? Sorry, 12 over 5r all over
1 minus R.
yeah.
and then I put that into my calculator. Oh no, can I just from there just make it 50r squared minus 50r plus 12 equals to 0? Or
4-mark question. I think you might just need to say this thing over here is the same as that.
yeah.
Okay, and if you just go through the steps, that's what you get. It might be enough. Question D.
So would it be? So I need to find out what A is first, don't I?
Yeah.
And so A is 12 over 5r.
Okay.
And
So 2 possible values for R. I just put into the calculator, that one. R takes the smaller of its 2 possible values. What is A?
R is 6.
So A is 6.
And so do I now need to use the formula for Sn, which would be 6 times um, 6 times R, or no, 6 times 2 over 5.
Yeah.
Minus 1. Oh no, 2 over 5 to the n minus 1 over 2 over 5 minus 1.
Yeah.
And then greater than 9.99.
Yeah.
And then just put that into my calculator.
Yeah. Try it.
I got n is 7.5388. So is it n is greater than? So is it n is 8?
N equals 8. N equals 8. Yep, there we go. And so that's how you go about those ones. Yeah, you're good. Any questions with that?
No.
Okay. This one looks very, very identical. Yep. Show that R is that. Yep, that's good. Find the 2 possible values of R. Find the 2 possible values of A. Given that R takes the smaller one, exceeds that. Great, got it. And so, sum to infinity.
I think I'll give it a tick.
That's good. This is killer. Sigma notation. Okay, let's go back. Let's see. Right, the first to exceed 1,000,000. This was last time. Oh, sum to infinity. When you're easy, you're so easy. A over 1 minus R. I like the questions where they just ask you find A or find R. Let's see. This one. Yes. What is this about up here?
So just, I'm going to guess, anytime there's conversion, I just need to think about the magnitude and it being less than 1.
Yeah, and that's why R in all these questions was like 0.5, 0.6, minus a half. It was always those little numbers. Otherwise, the numbers you add will just keep getting bigger and bigger, and so it'll just go to, they'll just add up to infinity every time, like 2 plus 4 plus 8 plus 16. So the numbers have to get smaller so that eventually they become 0. Let's see. Show that it's convergent. You just show that R is between 1 and minus 1. That the magnitude of R is less than 1. It seems like it's always putting in the same two formulas over and over again. A over 1 minus R and A times. It was actually easier to use the one where it's 1 minus R. So 1 minus R to the n over 1 minus R, because then you can times both sides by 1 minus R. Basically, you can just get rid of the denominator from both sides. That's how they made it much easier. That would have made that much easier. Although our way worked for a shot. Those are the easy questions. Yes, another thing. Hang on. Yeah, magnitude of R is less than 1. If R is 2x or minus 2x, then minus 2x, the magnitude of minus 2x is less than 1. And so the magnitude of x is less than a half.
Yeah.
You just solve that. This one, that was fine. Hang on. Value, bad question. They should have said values. All the other questions have values. Common ratio, that was good. You got that one. That was okay. This one, don't make my mistake of trying to simplify. BIDMAS, you have to do the power index before subtracting, but we don't know what the index is, so we can't subtract. Other than that, that's okay. This one, you got it. You nail it. That was the same. Yeah. How was that for you, Andrey?
Yeah, that was good. Thank you.
Okay, we're finally getting through this thing. Do you want to do next topic next or anything different?
Yeah, just carry on from where we left off there.
Okay. Any questions for me in general?
No, I don't think so.
All right. Well done, Andrey. You did great. I look forward to chatting again next time.
Okay. Thank you. Bye.
Have a good one. Good night.